Hello friends, welcome to my class. Now I am going to explain the horizontal projectile. So in the previous classes we have seen some very important concept regarding obliques projectile. Okay, now we are going to see the horizontal projectile. So what is the difference between obliques projectile and horizontal projectile? Okay, that I can say that only one difference. From that you can simply understand, okay, horizontal and obliques projectile. See, in obliques projectile, the body which is thrown in between x comma y plane having two components. So in the beginning, the body is thrown in between the x comma y, nothing but there is an x direction and there is a y direction. But here, when we come to the horizontal projectile, there is only the body which is thrown is horizontally. Nothing but the body is thrown, okay, in an x direction only. If you see this diagram, we can simply understand the horizontal projectile. Let us see. Okay. There is an x-axis and y-axis. Let us consider there is a building. Okay, a person is throwing a ball or a stone in a horizontal axis. See, in this way, it is only having a ux. Nothing but a person is applying some force and just it is throwing horizontally. Not like this. If it is thrown with some angle, there is a x direction and y direction. But if it is thrown in this way, just is horizontal like this, it is only having a horizontal velocity. So that's why I am writing as ux. But in this way, the uy will be 0. The initial velocity of the body in y direction will be 0 because the body is thrown is horizontally. In that case, what happens? After traveling t seconds, when a body which is after passing this, let us consider t seconds is traveled. So then that velocity of the projectile is called as the final velocity. Already we have seen in the last class. This velocity, let us consider after traveling t seconds, then that body divides into two components, or otherwise say you can say that body travels in two directions, that is horizontal direction and vertical direction. But before traveling of t seconds, the body which is having only one direction, that is horizontal direction. So this is Vx and this is Vy. If V is divided into two components, Vx and Vy. So these are, we know that this is a range or horizontal distance, that is Sx is equal, let us consider x. Now let us consider h is nothing but the height of the building or height of the some places from where the object is thrown horizontally with some initial velocity. Now let us try to understand the horizontal component is what and vertical component is what. Then after, let us find out this final velocity of the horizontal projectile. Also let us find out the time of descent. Listen to me, there is only time of descent is there. Time of ascent is not there, because the body which is coming from the highest point to the ground, the time taken from the highest point to reach the ground is known as the time of descent. There is a time, that is time of descent, to travel from highest point to from maximum height to the ground. Let us solve first. What are the Vx? So generally, when we take, let us consider V is equals to u plus at. So this is the first kinematic equation. V is equals to u plus at. So if it is applied for x but what? There is no ax, nothing but acceleration is 0 in x direction, so that this term becomes 0. You can ask one question, sir, ux is nothing but u cos theta. Listen to me. The initial velocity only having in horizontally, there is no initial velocity in a vertical direction. So means initial velocity doesn't have the components in the beginning, whereas final velocity is having the components. So that we can say Vx is equals to ux, that is equals to what? U. Okay, so this is the horizontal velocity. Now if you write it as Vy is equals to uy plus ay into t, just I am writing, okay, the velocity along x direction, velocity along y direction. So Vy is equals to uy nothing but 0 plus ay nothing but what? Ay, which is coming down, not is going up, so that we can write it as g into t, because as a is equals to plus z, it comes down, a is equals to minus z is going up. Okay, so there is Vy is equals to g and t. Clear? So this is the what? Component of final velocities. So from this we can write it as u, and this Vy nothing but we can write it as gt. Now let us find out some conditions for the horizontal component. Horizontal component. What are the horizontal components? Okay, so for horizontal component, ux is equals to u. There is no u cos theta, only u. Okay. And ax is equals to g and sx is equals to what? Yes. Okay. Then what we can find out from equation, that is kinematic equation, 2 implies. Okay. What is the 2? First one is v is equals to u plus at, and second one is s is equals to ut plus half at square. And third one is v square minus v square is equal to 2as. I am taking second one, that is s is equals to ut plus of at square. I am applying for this horizontal component, that is sx, ux and ax into t square. Sx nothing but x, because already we have seen in the conditions, and ux nothing but u into t plus this total term becomes 0 because there is no ax. Acceleration of the projectile in the horizontal direction is 0. This is it. Then x is equals to ut. From that we can write it as t is equals to x by u. Clear? Now, so horizontal component is completed. Now let us see second one is vertical component. Vertical. In vertical component, if we observe this, uy is equals to 0, sy is equals to what? Y. Sy is equals to y. This is y. Okay. And next, ay is equals to what? Ay is equals to coming down nothing but a is equals to plus g. Now write down in an equation, kinematic equation 2 implies that is sy is equals to uy into t plus of ay into t square. Sy nothing but y, uy nothing but what? Uy is 0, 0 into t, 0, then half into g t square. Then y is equals to half into gt square. Otherwise, you can write as y is equals to gt square by the y is equals to of gt square or gt square by 2. What this is? This is vertical component. Okay, vertical component, and this is horizontal component or horizontal distance or vertical distance. Okay, clear? So from that we can say y is equals to distance or height of the building, or from the horizontal surface to point from where the projectile is thrown in the horizontal direction. That is the distance or component. And next one, let us find out the final velocity of this projectile. What is the final velocity? What is the final velocity? So in the final velocity, you know that v equal to square root of vx square plus vy square. Then v is equals to vx nothing but there is only u, because where is that? This is the vx nothing but u, vy nothing but g and t. That we can write as u square plus gt into whole square. Clear? From this formula we will solve many problems for the final velocity of the horizontal projectile. If it is having u, that is horizontal initial velocity, and g nothing but acceleration due to gravity, and this is t nothing but time, that is time of descent. Now let us find out what is the time of descent value. Okay, let us find out time of descent. So before going to see, let us find out the angle between the horizontal velocity to the final velocity. Horizontal velocity to the final velocity. Okay. Now what is the horizontal velocity? Okay, listen to me. Therefore, angle that is tan alpha equal to, we know that vy by vx. Okay, vy by vx. Vy nothing but what? Vy nothing but gt. Vx nothing but, that is u. Tan alpha equals to gt by u. Then alpha is equals to tan inverse gt by u. Okay, so for this alpha is equals to tan inverse gt by u. So this is very important to find the angle between final velocity to the horizontal velocity. Okay, here we know that this is u. Okay. Now let us see some other equations like time of descent, and also we can find the range here. We can find the range. Okay, once you see this, once you take a screenshot, then after I am going to rub this, then I will write I will find out that is what time of descent and range. Okay. Yes, time of descent denoted by TD. create these values, that is x is equal to ut or u is equal to x by 3. Okay, time of descent. So for the time of descent, t is equal, let us find out here time taken by the body to reach the ground from the maximum height, that is time of descent, t is equal to td. Then okay, so what is u is equal to or vy is equal to what? Vy is equal to, that is gb, already we have seen. Then ay is equal to g, okay, or uy is equal to 0. From that we can find out, let us go through the kinematic equation 2, that is implies sy is equal to uy will be place of ay into p square. Sy nothing but what? Okay, sy nothing but this is the height of the projectile from where it is projected horizontally. That let us find out. Sy is equal to x. uy is 0 plus of, this is what, ay is equal to g td square, and h is equal to of into g td square. It's coming this side. 2h is equal to g into td square. Then td square is equal to what? Coming this side. 2h by g. Then td is equal to square root of 2h by g. This is the time of descent. Okay, time of descent formula for the horizontal projectile. From that also we can find the range. What is range? Range r is equal to, generally we know that range is equal to the product of the horizontal velocity and time. So here to apply range here, the product of the horizontal velocity, time nothing but time of descent. I am writing as td. Then r is equal to u into td, because ux is equal to u. Then r is equal to, okay, that is u nothing but u only. Okay, and this is td nothing but what? Square root of 2h by g. This is very important formula to find the range of this horizontal projectile from here to here. Remember? Okay, time of descent formula is this one, range formula is this one. Okay, and angle of the horizontal projectile this one, and the final velocity of the horizontal projectile is this one. It's a vertical component and horizontal component. Vertical and horizontal components. So from this, can we find anything? Okay, we have range and everything. Now let us see. Okay, so this is about the range and time of descent. So based on this, we can solve the many problems. So in the next class, or for the competitive exams like JEE NEET and other examinations. Okay, this concept is not important for IPE, okay, but it is only important for NEET and JEE and other examinations. Okay, thank you. So in the next class, let us see some very important problems based on this concept and also based on the obliques projectile concept. Thank you.